Hi everyone, welcome to Jawaras. In the previous video, we have seen some theory about access token, like what information we include in access token, how do we encode, decode, and sign it, and few more things. In this video, we will implement it. First of all, this is the access token request. In this request, we have the request method as post, and we send the request at token endpoint. That means in authorization server, we need to create one endpoint which will handle access token requests. Then we have few parameters in the request: grant type, auth code, redirect URI, client ID, and client secret. So we need to handle all these parameters and we need to generate the access token if it is valid. Otherwise, we need to respond with the error. I will not write the whole code here. I will just show you the code difference in GitHub, and then I will show you demo of the client server and authorization server working together. If you remember in the initial videos, we have created one confidential client from the scratch. So I am using the same confidential client to talk to authorization server, which we have been building in the recent videos. Client application and authorization server both are on our local host. So we need to differentiate between those two. So either we need to run authorization server on localhost and client application on 127.0.0.1, or the vice versa. So what I'm doing is I'm running the authorization server on localhost domain and client application on 127.0.0.1 domain. Why I'm doing that is, uh, even if their ports are different, if their that host name is same, then the cookies will be same or the session will be same. So if we change some cookies or some session in one application, then it will be changed for the second application as well, for the same browser. So it will cause a lot of issues and we will not be able to demonstrate it. So, but in real projects, what happens is authorization server is on some other machine or some other domains or some other host names. So then we don't get this type of problem. But we will get here if both have the same host name. So if both are on localhost or both are on 127.0.0.1. I will show you the code of confidential client application. So here if I go to application.properties, if you see, I have replaced all localhost with 127.0.0.1, and I have replaced auth2.auth endpoint from the GitHub's auth endpoint to the auth endpoint of our server, of our auth server, and our authorized server is running on localhost and port is 9000. So I have changed the auth endpoint and token endpoint. We have not created this token endpoint in our authorization server, but I will show you. I've created, but I will show you that now. And then we have user endpoint. So user endpoint we have not created. So if we send the request to this user endpoint now, we will see some error. Then I have added client ID, this redirect URI and client secret here. So in the redirect URI as well, the localhost has been changed from localhost to 127.0.0.1. And in the redirect URI, I have changed authorization code to OAuth, and I have included this client secret. So how I generated client ID, client secret, uh, these things I will show you at the end. But I think you already know that because we have already done that. The second is index.html. So index.html, we have connect your GitHub account. So I have changed it to connect your account. And if we have access token in our model, then I am just printing this access token here. Now we have this controller. So if you remember, we had this controller in the confidential client. So what I'm doing is I am adding this attribute access token. I have added this scope here. So scope email, profile, open ID, contact.read and contact.write. So we want to get the authorization code for these five scopes. And then I have changed this mapping because we have changed authorization code to auth here. And I'm just printing authorization code here for debugging purposes. And this is the access token URL. So here we can see first percentage. So this is token endpoint. Then we have grant type. code. So grant type was authorization code earlier. I changed it to code. Then the code will be authorization code, then redirect URI, and then we have client ID, we have client secret, and so on. So, so that is it. So we have not made any other changes in the confidential client. Now all the changes are in authorization server. So let's see that. So first of all, I will show you the controller which I created. Okay, so let's go there. I will create a new package called token, and inside token package, this is the token controller. So this is a REST controller because we don't want to return any view. All these requests will be back channel request, so that we don't need to return view. We just need to return response data. The first request mapping is to realms, then realm ID, and then token. So this is the token endpoint. Then I have included token service here. So what are things are in token service? I will explain that to you later. So just see what we are doing here. We have the realm ID here, and we have the this query here using request param. Then we have response. So what we are doing is we are getting all this information from the request, and we are creating a token request. So token request has something. I can just quickly show you that this is the token request. It is just a record with realm ID, client secret, grant type, code, and redirect URI. We need realm ID because we have the concept of realms in our authorization server. Then okay, I will again go to token controller here. So what we are doing here is we are creating this token request. Then we are asking token service to verify this token request, and how it is verifying that we will see later. Then if everything is successful, then we have seen that in case of successful response, we need to add this header cache control noise store. So that's what I'm doing here, cache control noise store. And after that, I am asking token service to generate access token response, and we are returning that. Nothing much here. Everything is done inside token service. So this is the token service. I'll go here. So we have okay, we are injecting realm service, client service, authorization service, and there is something else which is called key pair repository. We will see how it is being implemented, and we have token repository as well. So we will see that what is being done in these repositories. So I'm injecting everything using constructor injection. Now this is the method verify token request. So we have a token request, we need to verify it. So first we need to verify the realm. So how we are doing that? Okay, so this is verify realm. Yeah. So what we are doing is we have realm ID. So we are just getting this realm from the database using realm service. If it is not there, then we are throwing this error invalid token request exception. And this is the error description invalid realm. Now let's see how we are handling this invalid token request exception. So this is invalid token request exception. So you can see it has error description, and error URI. It has some constructions. You can go over them. So I will just click it as viewed. Then we have invalid token request, invalid client exception. And this is subclass of invalid token request exception. So what this class is doing is it is making error as invalid client, and error description client is not valid. And okay, here we are handling those exceptions. So the first is we are handling this invalid token request, invalid client exception. So in this case, we are creating a problem detail, and the status is unauthorized, and we are returning that. And this method, what this method create problem detail doing is, it is just taking the exception, the status code. So it is creating a problem detail with the title, uh, and title is the error, and the if description is not empty, then we are including error description. If the URI is not empty, then we are including error URI as well. And here we are setting the status. and we are returning this problem detail. And the second method is handling invalid token request exception. And in this case, the status would be bad request, because we have seen that if the client is invalid, so in case of invalid client, the status would be 401, and in all other case, the status would be bad request 400. So that's why we have two types of um, exception here. We could have done this with one exception only, but I find it more useful to have two exceptions. And we will handle the most specific exception first. Okay, so that is it. Now let's go to token service again, what we are doing here. So we are verifying rel. Now in order to verify the client, we are doing the same thing. So here we are passing the whole token request. So if client ID is present in the request, then we are trying to fetch it. If the client is not valid, so the client is not present with the given client ID, then we are throwing invalid token request, invalid client exception. Now after that, if we are checking if the client is confidential or not. If it is not confidential, then we don't need to check the client secret, so we are just returning, that means the client is valid. Otherwise, we are validating client secret as well using client service. If it is not valid, then again we are throwing this invalid token request, invalid client exception. Now let's look at this one, that how we are validating client secret in client service. I will just go to client service here. Okay, so now here we can see we are validating client secret. So we have client ID and we have the client secret which the user or which the client application provided us. So now if you remember, we have this concept in our application that one client may have multiple client secrets. So what we are doing is we are getting all available secrets from the client secret repository, and for each, we are trying to match with each client secret. And how we are doing is we are taking the, so this is the secret which is stored in the database, and this plain secret is the one which the client application provided us. So we are getting the salt from the secret which is stored in the database, and then using that salt and the plain secret which the user provided, we are calculating the hash, and we are comparing this hash with the hash which is stored in the database. If both are same, then it is match. And if anywhere we find match, we are returning true, otherwise we are returning false. Now in the client secret repository as well, I have added this method find by client ID. So this method finds all the secrets with the given client ID. So I will just mark it as viewed and mark this also as viewed. Now, okay. Now let's again go back to the token service. So in the token service, we have seen how to validate the client. Now after that, we are verifying the grant type. So let's see how we are doing this. So in order to verify grant type, so if the grant type is not present, then we are throwing invalid token request exception with this error description. Otherwise, if the grant is present but it is not equal to authorization code, so in that case in that case the error code should be unsupported grant type, and the description can be anything which you want. Here I am just um, giving the error description grant type must be one of authorization code or client credentials. Okay, but I should have checked for client credential as well, but I'm not doing that because I'm not handling client credential here. I'm just handling authorization code. Apart from that is invalid. So this error description is wrong. It should be grant type must be authorization code, but whatever. So you can do whatever you want. So after verifying the grant type, now we need to verify the code. So if you see, we have the authorization code as well in the token request. So we need to verify whether that is valid or not. So first of all, if the code is not valid, then we throw invalid token request exception with code is required description. Otherwise, we will try to the code is in encrypted and encoded format. So we need to decrypt that, and then we need to decode that. So what we are doing is we are getting the authorization code from authorization service. So in the authorization service, we have decode authorization code method, and it will take a string and it will return back the authorization code. So let's see. I think I have covered that in the previous videos, I guess. So, but let's say in the auth. Okay. So that method is already there in the authorization service. So that's why I think we are not finding. Okay. So let's see here. Yeah, this one. Yeah. So here, this is the one decrypt code. Not this one. Yes, decode authorization code. So here we are getting encrypted code here. So first we are decrypting the code, and then we have a method in authorization code class which will create actual authorization code from a string. So we are just calling these methods. And one thing to note that uh, wherever we had base64.get encoder, I have replaced them with base64.get URL encoder. And similarly, decoder is changed to URL decoder, so that it is safe to uh, transfer the data which is URL encoded. But if it is just base64 encoded, simple encoded, then when you transfer data using network request, then it may get changed. So that's one thing to keep in mind. So whenever you need to encode or decode the data which is meant to be sent to some other service using network, then you should always use base64 URL encoder or decoder. Okay. So I will just one more thing is that in the auth controller advice, I have replaced error underscore code with error only. That is one thing. And let's go here again. Token service. Now we are verifying the authorization code. Okay. So now if there is any error while getting this authorization code, then we are throwing this exception invalid grant. So in this case, error code is invalid grant because the authorization code is present in our request, but it is not valid. So I can say invalid authorization code. Now, and also I am saying ex.init cozy. So and then we are throwing this exception. We are throwing this runtime exception so that we can throw valid response to the user or to the client application. Now, after the first step is we need to verify the client ID, whether the client ID which is in the authorization code matches to the client ID which is in the token request or not. If it doesn't, then we throw invalid grant. Client ID does not match. Then we need to verify whether the token is expired or not. So if it is expired, then we say invalid grant, authorization code is expired. After that, we need to verify whether the redirect URI is a match or not. So there are two redirect URIs, one in the authorization code, the another in the token request itself. So both should match, otherwise invalid grant, invalid redirect URI. Now, one thing to note here is that we have not checked whether this authorization code is already used or not. Now, how do we do that? We have not done that here, but what we could have done is we could have created a cache here. Cache can work in a way such that all the entries added before 5 minutes will be deleted. So in that case, what will happen is whenever we get an authorization code, then we check in the cache if that authorization code is present or not. If it is present, that means we have already processed that authorization code, so we will return some error. Otherwise, we will create access token and then we will put that authorization code uh, in the cache. And after 5 minutes, that authorization code will be removed from the cache. But that is not a problem because uh, in at that time the authorization code itself have been invalidated because it has been expired. So that's very important thing which we need to keep in mind. Also, I have discussed that there are two approaches to use authorization code. One is having all the information in the authorization code. The second one is storing authorization code in the database. So if we store authorization code in the database, then this becomes simpler because whenever we see any authorization code, then we just look it in the database if it is present in the database or not. If it is present and if it is not expired, then it is valid, otherwise it is invalid. And if it is valid, then after sending the access token to the client application, we can just remove that row from the table. And if we see that authorization code again, then we can say that this is invalid. Or instead of deleting that authorization code from the table, we can mark that as used authorization code, and whenever we get another request in that 5 minutes window, then we will see that this is already used. So in that case, we can just revoke the access to previously generated access tokens. So that is one thing to keep in mind. Now let's say everything is perfect. So we have verified the token request. After that, we need to generate access token response. So the controller is calling this method to generate access token response. So first of all, we need to create the access token itself. So first of all, we go to the authorization code from the authorization service, and now we need to create access token. So I have created one class here called access token here. So this has something. So issuer, who issued the access token. So generally the authorization server itself. Then expired set. So when, at which time the access token will expire. The audience for which this access token is created. So this is generally the URL of the resource server, and it is not used that occasionally. Then we have subject. This is the user ID or username of the user for which we are creating this access token. Then we have client ID. So client ID is the one who is requesting for the access token. Issued at. So this is when the access token was issued. Token identifier. This is a unique identifier of the token. And then we have scopes. This way separated list of scopes. Now, so this is one static method to create the access token. So what we are doing is expiry time will be issue time plus 2 hours. So this access token is valid for 2 hours. Now, okay, so that is done. Now I will go to token service. Okay. So in the token service, yeah, here. So while generating the access token, this is the issuer. So issuer is, this is the URL of the authorization server. And we are adding this realms and realm ID as well, and API default. So if you don't want to, deal with audience, you can just use API default here. Then we have authorization code dot username. So this is the subject, which is the username, and then we have client ID and scopes. So now we have access token. Now we need to create a refresh token as well. So what we are doing is we are delegating this responsibility to the token repository. So let's go to token repository now. So this is token repository. So we have JDBC client here. So what we are doing is, so first of all, we need to generate a refresh token, which is a random string. So we are generating random string of length 32. Okay. Then we have this expired set. So expired set means like when will this refresh token expire? So we say that this will expire after 1 day. Then we are inserting all this information of the access token and this refresh token in the table, so that whenever we need to create a new access token using this refresh token, so we can create new access token using this information. So we are, this ID is the refresh token itself, and we are storing issuer, audience, subject, client ID, this is scopes and expired set. So this expired set is the expiry time of the refresh token, not the access token, because we don't need to store the expiry date of the access token, because whenever we need to create new access token, then the expiry date will be created based on that time. So let's get that out of the way, and again go to token service here. So we have the refresh token. Now after refresh token, we need to generate access token response. So I will create another method which takes refresh token, access token, and the realm ID, and it generates the that response. So this is the method, I guess. Yep, this is generate access token response. So we have refresh token, we have access token, and we have realm ID. So first of all, we need to encode the access token. because we cannot just send it in the JSON format. We need to encode it. So that's why we are doing here encode access token, and this is taking access token and realm ID. So this is the method to encode the access token. So we have access token and we have realm ID. So first of all, we need the private key for this realm. So now what we could have done is, let's say we have one pair of private key and public key for the whole authorization server. But what I think was, the good approach is having one private key, public key pair for each realm. So that's what we are doing here. So we have key pair repository here, and we are getting the private key from this key pair repository. So this repository will give us the private key for this realm. And how we are doing that, we will see that later. After that, we are signing it. So we have a JWT signer. So I have created that class. I will explain the code of JWT signer as well. And we are creating new instance of it, and then we are signing this access token using this private key. So in order to sign it, we need two things: access token, private key. So this is access token and this is private key. And otherwise, if there is any error, then we are throwing a new runtime exception. Okay. So I think, yeah. So now we have encoded access token. After that, yep, this one. So we have access token. So this is the response which you need to return. So this will be a map of string to object. The first is access token, and its value will be this encoded access token. So you can see we are returning a map. The first key is access token and its value is access token encoded. The second is expires in. So this is when the token expires. So what we are doing is we are just subtracting this issued at from the expired date of this access token, and we are getting the expires in. So this is expires in. So this means that after 3600 seconds, this access token will expire. So the client application needs to generate a new access token. Now you might be wondering, why do we need this information when we have this information already in the access token? The thing is, this access token is opaque to the client application. That means client application does not know what is the access token, what is inside it, uh, because for client application, this is just a random string. So client application should not or must not read the access token. It just needs to get it from the authorized server and send it to the resource server and store it somewhere. But it should not interpret it, it should not read it. So that's why we have expires in here. So that client application will know that okay, after 3600 seconds it will expire. So what it will try to do is, let's say after 3500 seconds, it will try to renew access token. After that, we have token type. So this will always be bearer, because we will send this token in the authorization header with bearer prefix. Then we have refresh token, and then we have refresh token expires in. And we are saying that refresh token will expire after 1 day. That means 24 hours. Now in the realms service as well. So after creating this realm, after saving this realm in the database, we are generating its key pair. So this is a new realm. So we need to generate its private public key pair. So we are generating that using key pair repository, which we will see how we are doing that. But before that, let's look at schema.sql. So here we have two new tables. First is realm keys. So this table stores the private public key pair for each realm. Then another table refresh tokens. So this token stores the refresh token when the refresh token will expire, and some information of the access token, which we have seen in the token repository. And what is in the database, data.sql? In the data.sql, there is no like useful information. And these are some tests. Okay, so I did some tests here as well. So you can look at those tests if you want. So here in the crypto JWT signer verify test, you can see how we are using JWT signer and JWT verify to sign and verify the any information. So one thing to note is that the JWT signer or JWT verifier are not limited to access token. Uh, you can you can use them to sign and verify any kind of information, but the information will not be hidden. So it will just sign the information, but the information will be visible to anyone. So that's why we cannot use this mechanism for authorization code. If we want to use the same mechanism for authorization code, then we need to encrypt using some uh, private key, and so not from the private key, using some secret key. So there will not be any public private pair. Let's look at key pair repository. So this is a repository which is responsible to maintain the private public key pair for each client. So if you can see, we have a map of string to key pairs. Here is string means realm ID. Key pair is the private public key pair for that realm. Now here we have a post construct method. So post construct method is used to perform some actions just after the creation of this bean. So whenever an instance of key pair repository will be created, then we will invoke this init method. So what we are doing is we are selecting the all three columns from the realm keys table, and we are performing something. So what we are doing is we have realm ID, private key, and public key, and we have this private key and public key in string format. We need to convert them in private public key pair format. So that's why we have add realm with keys this method. So if I go to this method, add realm with keys here. So we have realm ID, private key, public key. So first of all, we are creating private public key pair using private and public key. So for that we are using this method, create key pair. So this create key pair. So what we are doing is from the private key, which is in a string format, we are creating the actual private key, and from the public key, which is in a string format, we are creating the actual public key. And then we are creating a new key pair using this in key pair constructor. So let's see how we are converting this string into private key and this string into public key. So there are these two methods, create private key from string. So create private key from string. So this is the code to convert any private key which is in string format to the actual private key. So we are decoding it, and we are decoding it using base64 URL decoder. And this private key, yeah, and there can be many algorithms to sign the data, but we are using RSA algorithm. So we are creating instance of key factory using RSA algorithm, and then using this encoded private key, we are creating an instance of pkcs at encoded key spec, and then using these two, we are creating a new private key. And in order to create a new public key, instead of pkcs at encoded key spec, we use x509 encoded key spec, and then we can create a public key. So I will include the link of this documentation. So there is a good article from Oracle which explains like almost all of the things which you can do using cryptography in Java. So it has information like encoding, decoding, encryption, decryption, hashing, signature, and like private, public key, secret key. Everything is there. So you can read that article. So I also read that article and then came up with these methods. Okay. So now we are putting everything in this map. Why we are doing this is because let's say whenever we need to get the public or private key of the realm, then we don't want to do look up to the database each time. So that's why we are doing that. Now there are some method as well. So there is one method to insert key pair. So we have realm ID, private key, and public key. So we can insert that using JDBC client. So then we need to generate keys for realm. So if you remember in the realm service, we are calling this method. So whenever we are creating a new realm, we are calling this method to generate private public key pair for the trail. So what we are doing is we are using key pair generator, and using this key pair generator we are creating private and public keys, and then using this private and public keys we have one method here in this class which converts those private and public key to into strings, and then we are putting uh, those strings in the database, and we are putting the this pair in the map as well. So yeah, here this is the method, no, not this one. Okay. Hmm. Okay, this is the method. Okay, we have this method get key to string. So what we are doing is base64 URL encoder to encode to string. So in the private key and public key class there is a method called get encoded, and so this will return the byte array, and we are encoding that byte array to string, and then we are returning that. So that's what this repository is. So this repository is responsible to keep a map of realm id to a private public key pair, and so using this map we can, and whenever we want we can get the public key or private key, or public key and private key in string format for the given realm. So that's the responsibility of this repository. Now let's look at JWT signer here. So this is the JWT signer. It is taking data and a private key. So what we need to do is we have this JWT header. So we are using algorithm RS256 only. That means SHA 256 with RSA. That's why we have this fixed JWT header. Otherwise, if our authorization server wants to support some other types of these algorithms as well, then we need to create JWT header as well dynamically. But here we the header is fixed, so its type is JWT and algorithm RS256. So this is the header. So what we are doing is first we are creating an instance of signature. So signature, this is defined in java.security package using SSA256 with RSA algorithm, and we are initializing it with the, this private key. Now after that, so this is JWT header, but we need to encode it. So we are encoding it using base64 URL encoder. Now we have data string. So what we are doing is we are getting this data here as parameter, for which we want to create this JWT token. So we are first of all we are creating JSON representation of this data using object mapper. So this is the object mapper, and after that we are encoding this as well, just like we did for header. Now what will be the input to our signature algorithm? We have seen that here, I guess. Here we have encoded the header, we have encoded this data as well. Then we will combine both of these, and there will be a dot in between these. So the input to signature will be JWT header encoded plus dot plus data encoded. And after that, after this, we will update this signature algorithm with this input. So it requires byte array. So we will, this is the string. So we will call get bytes method on the string to get the byte array. And after that, we'll just call sign method to sign this byte array. So this is the signature. Now we need to convert the signature from byte to string. So for that, we are again using base64 URL encoder. And after that, we will append this signature to the original input with a dot. So you can see here, we have the signature, and this signature as well is appended here. So this is JWT signer. Now there is another class called JWT verifier, which is not used in this authorization server. We are using it in this test, but it is not used in the authorization server anywhere else. So the similar thing which we can use in the resource server, and we will do in the later videos when we will create a resource server. So this is JWT verifier. This is doing a similar thing. So I will not explain this code. So you can look at this code, and it is very easy. It is self-explanatory code. And also, as I have said before, I will provide a link of that documentation which includes all of these cryptography things in the Java. So looking at that documentation, these will be like very easy to understand for you. Now there is another class called invalid JWT exception. So I am throwing this exception whenever in the verifier, whenever it is not valid or it is not verified. Now there is one, I made some changes in readme.md file as well. So here I have added one link to the Postman collection, which I used to create Realm client scopes and these things. You can look at that if you want. Now I will give the demo here. So this is authorization server and this is confidential client. So I will just first run the authorization server application. So I will run it. Okay, it is running. And now I will run the confidential client application. Okay. So if you can see, authorized server is running on port 9000 and confidential client is running on port 8081. And this is the Postman collection. So this is a create realm request. So this is how I created the realm. Now for this realm, we need to create scopes. So this is how we create one scope. So let's say you want to create another scope, you can just say contact.read or like contact.edit, contact.delete, whatever this is the name. So we have covered that. This is the request to create a new client. This is the request to create a new client secret. So here you can see whenever we are creating a new client, we are saying this is confidential or not. And this is the request to get the access token, but we will not use that here. We could use, and if you use it, it will work. You just need to provide correct authorization code, client ID, and few things. But we will just go to the browser for now. So I will open the browser. I'll go here, new incognito window. Let's go to 127.0.0.1. As I have mentioned earlier as well, the host name for authorization server and resource server should be different. 8081. Yeah, I will just zoom in. So we have connect your account, and if you want, you can see in the network tab whatever you want. Now we need to log in to Java realm. So the username is user1 and we have some password here. Now you can see we are asking for all these scopes. Now let's say I don't want to give this edit your contact scope, and I will click on allow. Now you can see we have uh, this access token. So this is the first part of the token, which is the header. This is the second part of the token, which is the token data itself, and this is the third part of the header from here to like a very end, which is the signature encoded in base64 URL format. So let's just copy this, and there is this website called jwt.io where you can go and paste it to view the content of the token. So I will just go here and I will paste that here. So now here you can see the header type is JWT and algorithm is RS256, and this is the payload. This is issuer, this is expiration, this is audience, this is subject user1, this is the username, this is the client ID, this is IAT, this means this is issued time. Then we have JTI, so this is the unique identifier for the this access token, and then we have scope. So you can see scope is open ID, profile, contact.read, and email. So we don't have contact.write here because the user unticked that box. So this is how we generate the access token. Yeah, I guess that's it for this video. So I hope you learned something new in this video. So as always, this code you can find on the GitHub. So I have already raised this PR. I will just merge it now. So you will find this code in my GitHub repository, and I will provide you the link to learn cryptography in Java. Thank you everyone for watching it, and bye.